What we've done so far with parabolas is just the regular forms. Your ax squared plus bx plus c. You did the, excuse me. We've done y equals ax squared plus bx plus c. We've done y equals ax minus h quantity squared plus k. That was what we called vertex form.
Yeah.
And then we did intercept form.
Q.
Yeah. X minus P, X minus Q, where P's and Q's are your zeros. Well, the other way that we write these things out is what's called conic form. Conic form is very similar to vertex form. Very, very, very similar to what vertex form looks like. But what we're going to do today is we're going to center our parabolas at the origin. And I'm going to show you guys that you can have a parabola that goes left and right, as well as up and down. Okay. So we're going to have parabolas that go other directions now. So we have this new form that's going to look like this. X squared equals 4py, and y squared equals 4px. These two forms are, like I said, they're quadratic form. These are for when the parabolas are centered at the origin. An x squared parabola centered at the origin is going to go up or down.
What are these called?
These are conic form. This is a conic form. Conic. That's what we're looking at here. This whole unit here. They're conics. It really won't take long to go through this. We're going to look at parabolas that go up and down, open to the right, open to the left. We're going to look at ellipses. Ellipses are like squished circles that go up and down, left. Oh. You're right. We're going to look at what are called hyperbolas. Hyperbolas have some fancy things going on, and we're going to be graphing all this cool stuff. You're going to open like this, or they'll flip and go the other direction, as well as our favorite one in the whole world, circle. Those are the easiest ones. But what we're going to start with is just to get used to this new format. It's really quite simple. What happens with parabolas, and we haven't really studied a lot of this before, is that inside parabolas there are a whole bunch of different pieces that make them work. You have all these different symmetries. Remember when you had a parabola, we had that axis of symmetry, that vertical line that all the points were equidistant to? Well, what happens here is you also get what are going to be called excuse me, focus and a directrix. Now, what I want you to think of here is every parabola, whether it's opening upward or downward, left or right, every parabola has a vertex. Let me draw this in clean so it's not so bad. Every parabola has a vertex. Every parabola is opening towards something. When you're looking at something, you're focusing on it. What is it there? The focal point, right. This focus is always on the inside of the parabola. Whether the parabola is opening upward, to the right, downward, or even to the left, the parabola will always look at the focus. What's behind it is this balance. There's this equidistant part called the directrix. The directrix is kind of, the easiest way I can think of it is a balance point. Have any, yes sir?
So it's equidistance from the vertex to focus from the end of vertex to the...
Yes, and this is where that value of p is going to come into play. So this is for a parabola that is an x squared. This distance between here and here is the value of p. If it's positive, the p value goes up. If it's negative, the p value goes down. This value of p tells you how far you are from the directrix to the vertex, or from the vertex to your focus.
Like, from the focus to the vertex speed.
Yeah, if it's up, and then if it's down, it would be a negative thing. Once I show you in terms of how you solve for it and work through it, working with directrix and focus, it looks like it's weird, but it's really, really very easy to work with and how we're going to plot these things. Yes, ma'am? It's the perpendicular spot. What the directrix is going to be, if it's up or if it's down, it's going to be y equals some number. Okay, it's going to be a horizontal line. If it's left or if it's right, it'll be x equals some, it'll be a vertical line. So this directrix is, if it's opening upward, it's always going to be y equals some number for this directrix value. What'll happen here is you're going to be using ordered pairs and just counting up and down with them. Okay. Like I said, for today, we're going to start everything at the origin. As you go out, and if you wanted to start figuring out why all these things occur, and I didn't want to get into the whole, really kind of the calculus of it, is that each point on the curve will always be equidistant to the directrix and the focus as it's going through. You guys ever see or ever played with like glass lenses where you change how things look? I mean, basically, it's just like wearing glasses, how things are curved. That way, inside the back of your eye, you can see it better. That's the whole idea of this focus and the directrix. It's like the in part of your eye. The image comes in your eye and it's bouncing off the back of things. If those things are out of whack, like most of us, we have to wear contacts or glasses to help keep these things in focus. That's what these things are doing. You have blurry vision because all those distances aren't equal. That's how they change the curve of things to help you focus better. Get it? Looking at it, I know. There's actually a reason why we know things about math, because it helps us to see. So let me show you how this works. What'll happen, don't write all this out right now. What happens here is that there's going to be 4 very basic things to look at. What'll happen is, as we start going through some of these things, if your p-value is positive, if it's an x squared, it'll be up if p is positive. It'll be down if p is negative. It's pretty much what we're looking at. If it's a y squared, which direction do you think it would open if it's a y squared and your p is positive?
To the right.
It's going to open to the right. That's all it is. And if it's negative, it goes to the left. The idea here is, well, first of all, if you look at your calculator, there's a button on the calculator that says y equals. Everybody agree on that?
Yeah.
So what will happen is if we wanted to graph a y squared parabola, we'd have to get y by itself. Well, how do you get y by itself in this case? Square root. And notice you'd have to take the square root over an equal sign, so you'd have plus and minus square roots. That way you can have a square root graph going up and a square root graph going below it. That's how you get your parabola. That's how that'll work. It is very simple to do. So if it's opening to the right, that means p is positive. If it's opening to the left, that just means p is negative. All of these things here are showing that. This value, if it's opening upward, it means the focus is on the inside and the directrix is below it. Focus is below it, directrix is above it. That's how we flip these things around. Let me give you an actual example of something centered at the origin and show you how we can calculate where these focus and the directrix are going to be. You'll be happy to know it's usually one step. We can come back to this here in a second. Let's look at x equals negative 1/6 y squared. And I'm not going to use graphing. I'm going to walk you through how this sets up. So if I have x equals negative 1/6 y squared, you could probably tell right away that it's either going to be left or right or up and down. Which one will it be?
Down.
Is it an x squared or a y squared?
It's a y squared.
It's a y squared, so it means it's gonna go left or right.
It's
That's
gonna go right.
That's how this is gonna look. If there's a y squared term, it's either gonna open to the right or it's gonna open to the left. Okay? That's all that means.
It's gonna open to the right.
I wanna get the y squared by itself. How do I move a negative 1/6?
Add.
Oh, it's multiplying.
Divide.
So negative 6x is y squared. We okay with that? Are you okay if I flip them and write y squared first?
Yeah.
So I have y squared equals negative 6x. So now I'm at a y squared equals negative 6x. Everything is centered at the origin today, which means I need to work with the following equation. Y squared equals 4px. What I'm going to do here is solve for p. The coefficient of x, I set that equal to 4p. Therefore, what's my p value? Just divide it by 4. So you have negative 3/2. That means my p value is negative 3/2. So here's what you use with that. We know that this is going to be a graph. It's going to be centered at the origin, which means my vertex will be at 0, 0. The p value tells me what direction it's moving. Since it's a y squared, that means it's opening to the left because it's negative.
Yeah.
Okay? It's opening to the left because it's negative. The p value is the distance from the center to the focus, which gives me a focus at negative 3/2, comma, 0. I just moved over negative 3/2. Yes, ma'am? Okay. From there, it has to do this. I'm not worried about ordered pairs on the curve. I'm just drawing the curve for today. Yes, sir?
Wait, if the green is the equation, then is the blue the focus or
The p value, we're going to get to the p value tells you what direction you're going to go. I'm just going to find the focus first. That's usually what I do. Find that first, and then I go backwards to get the directrix. So now the directrix, when I go the other way, opposite of negative 3/2 is 3/2. Now I have a directrix. At x equals negative 3/2. Because it's vertical. Yes, ma'am? There's no shift. We're starting everything at 0, 0 today. Everything's going to be centered at the origin for today. Yeah.
Wouldn't it be 3/2, not negative 3?
Oh, did I write 3? Yes, sorry. Thank you. Yeah, just positive 3/2, excuse me. So what I want you to see here is that when you are you have x squared 4px, excuse me, 4py, and y squared equals 4px. That p value tells you the direction that it's going to open. If it's an x squared, it's going to open up or down, depending if it's positive or negative. If it's a y squared, it's going to go left or right, depending if it's positive or negative. All you're doing is taking that coefficient, that negative 6, I'm setting that equal to the 4p, and it tells me my p value. And then I just walk it whichever way I need to go. What'll change from this to when we do this tomorrow with the shift points, instead of starting at the origin, we'll start at 3, 4, and then walk some value x or some value y, and that's it. Okay? Just trying to. So we have, let me rewrite this here. So it's 3/4 y squared is x. I want to do the same basic idea. Excuse Excuse me. I want to get it into the generic form, which is y squared or x squared by itself. This one obviously is a y squared, so it's going to open left or right, depending upon what we set it up as. How do I move to 3/4? By 4/3. Good. So that means y squared equals 4/3 x. What I'd like you guys to get in the habit of doing when you get to this part is write down the generic form. Y squared equals 4p x. So now you can set 4p equal to 4/3. Which means divide by 4, and you get 1/3 for p. So if p is 1/3, what direction is it going?
Right.
Correct. Since it's positive, it means it's opening towards the right. So center at 0, 0. Focus at 1/3, 0 is my focus. Where's my directrix? Negative 1/3. My directrix then will be at x equals negative 1/3.
You're right, -1/3 times 0.
Yes, because it's just that you're just telling me that's an ordered pair. The directrix is a line. It's an imaginary line. Because as these things curve themselves through, this point, the distance from here to here is the same as here to here. So that's how that works. You'll notice that the values, the 1/3, that helps open and close the parabolas. I'm not really concerning myself with where does it have to be absolutely perfect on these curves and parabolas, because once we start going with finding the directrix and the focus and where these points lie, it's kind of the same thing over and over and over again. But what I wanted to show you after I gave you a couple examples was just kind of the generic form of how this will always work. In an x squared parabola, when we're centered at the origin, no matter what. Yeah, that's fine. No. Thank you. So what happens here is that if it's an x squared, your focus, since we're centered at the origin, is always 0, comma, p, whatever that p value is. Whether it's positive or negative, that just goes there, your focus. The directrix is always going to be y equals the opposite of p. Because it's going to be a horizontal line, which is up like a cup or down like a round. The axis of symmetry, obviously, we're at the origin here, so it's going to be vertical at x or horizontal at y.
Always pick origin?
No.
No.
They both run h and k in here. You'll see it's really quite simple for both h's and k's. And then the other one, for the y squared, it just flips. It just flips itself through. And then x equals the opposite of p. No. Thank you, sir. Appreciate it. So, like I'm saying here, it's a matter of getting the x squared or the y squared alone by itself first, and then just working yourself through it. It's a matter of just plotting them out and walking backwards and forwards. Not trying to make this thing all crazy and such, because that's just messy after a while. Let's try another one. Let's see, we have done x squared? All right. Well, let's just do the first one then. This is pretty easy. Let's do an x squared. X squared equals 4y. What's our p value? You can probably do that in your head. Correcto. So I've had x squared parabola. It's already by itself, so I don't have to worry about anything. So I have the generic form is x squared equals 4py. Therefore, 4 has to equal 4p. What's your p-value? 1. The p-value is positive, so is this up like a cup or down like a frown? Up like a cup. So I know that's going to be at the origin. 0, 0 is my vertex. My focus will be at 0, 1 is my focus. And then my directrix will be at y equals -1. And it just goes through. And that's really it. Yes, ma'am.
Where'd you get the 4p, like the 4 equals 4p? Right? I'm just saying like.
Every one of these has a generic form. The generic form is always going to be x. If it's an x squared parabola, it's going to be x squared equals 4py. If it's a y squared, it'll be 4px. What we're doing here is we're using this value of 4p to figure out what is the value of p. Because this p value tells me how far I'm moving it upward or downward within the directions. Okay? Yeah.
What's the negative one?
The negative one is there's a what's called a, and you guys walked in a little late on this one. When you have a parabola, think about how your vision works. When you see stuff coming in, it bounces off something in the back of your head, and you're focusing on something. Well, if that focusing points aren't all equidistant, it's blurry. That's why you have to wear glasses or contacts, because they're trying to get these distance from the focus to the vertex, and this vertex to what's called the directrix. Those distances have to be the same in order for you to be able to see clearly.
Oh, so it's kind of like an axis of symmetry, but it's like a different thing.
Yeah, it's a little bounce point if you want to think of it that way. Because what'll happen is, the further the focus is up, the tighter the curve is going to be. The closer the focus is, the wider the curve becomes. Because this point will move it up, and it draws it in. As it comes closer, it opens itself out.
Umbrella.
Exactly. It's much like an umbrella. Much like an umbrella. So when we're working with these values of p, whether it's up like a cup or left or right or anything like that, you do the exact same thing each and every time to figure out that p value, to know where it's going. Okay. Let's do the 8y squared. 8y squared equals x. If I do 8y squared equals x, excuse me. It's obviously an x squared.
Y
Oh, sorry.
I was like,
Sorry, obviously it's a y squared. I was reading something else. So you got to get the y squared by itself. So I'm going to move the 8 over. So I get 1/8 x. Y squared equals 1/8 x. After that, I'm always going to write y squared equals 4px, which means I'm going to set 1/8 equal to 4p. Very good. So 1/8 equals 4p. Multiply both sides by a 4. So my p value here is 1/32. Okay. Well, you don't have. Well, here's the thing. We're not trying to mark that off perfectly. Y squared, it was a positive p value, so is it going to go left or right? Which way is it going? It's going to go to the right. Good. So, this is going to be all graph. We'll just put 1 out a little bit further. It's still going to be centered at the origin. Your p value, just the distance from the center to the focus. So it's going to be at the ordered pair. 1/32, comma 0. The directrix is equidistant behind it. Is that going to be x equals or y equals? X equals. It'll be x equals negative 1/32, and then it's just going to open outward. That's it. Okay. The only pseudo trickiness can come into play when they give you the directrix or give you the focus and write the equation. Yes, sir.
Okay, so like, how do you figure out how wide the, like,
For right now, you just draw the curve. I'm not. You'll learn in time that the smaller the value of p, the wider it's going to be. Yes, sir.
Will it ever like not be at 0, 0?
Yeah, we'll get there. It's easy. Very, very easy. You have to trust me.
You're dividing by 8.
Let's just say we have
1/8.
this. We're centering it still at the origin, and let's say I have a directrix at y equals 2. If I have a directrix at y equals 2, the vertex is at 0, 0. Vertex is at 0, 0. Y equals 2. What way is this opening?
Down.
Very good. Everybody see that? If the directrix is above you, that means you're opening downward. If the directrix is to your left, it means you're opening.
Correct.
If the directrix is to your right, you are opening. That's all it is.
Why are you
You're-
opening downward?
The directrix is always opposite the direction of focus. Okay? So if the directrix is above you, that means you have to open downward. How far was the directrix to the vertex? 2. So how far is 2? So is your p value positive or negative? Negative. So p is -2. Therefore, the equation becomes, it's an x squared parabola because it's opening down. X squared equals, well, 4 times -2 times y. X squared is -8y. You're putting a quick little plot of where the directrix or where a focus might be, and that'll allow you to know what direction you're opening. With parabolas, you're always going to open to your focus. So if they give you a directrix, it means it's behind you, no matter where it goes. The directrix will always be behind you. Bless you. Bless you. Oh, you didn't get that last one. All right? That's all this means, guys. It is, let's say I have a, just real quick, because I know we're running a little out of time here. Oh, never mind. I don't think we need to do that in any of these. I really don't. Let's do this. So let's go 23 to, we'll do 23 to 61 every other odd, and then 67, 69, and 71.
What do you mean every other odd? Do you mean like
23,
1,
27, 31, 35. So it's just go increments of 4. How's that?
every 4?
What, 23 plus 4 is 27, 31, 35, 39, 43, 47, 51. So 51, 55, 59. Oh, this should be 63. 61 won't work. It'll be 63. So, actually, probably could have just gone all the way up through these then. Oh well, no big deal. There's nothing crazy. There's nothing scary to this stuff here, guys. What we'll do tomorrow is we'll throw it in where you're going to have y minus 3 equals 4x minus 2 quantity squared. It's very, very similar to standard form, or to the vertex form, but we're able to figure out that p-value by plotting out focuses and stuff like that. It shouldn't be difficult. Hopefully, don't mess around.
23 through 71.
Yes. It's like, well, they're really easy. They're really easy.
Bad name.